Today we're going to talk about OLED screens and SPI communication. So we've been using the serial monitor for output and little LED lights for some blinking lights, but we need a better way to present user information to the user. Imagine if you had a smart toaster or an Amazon Alexa, you wouldn't want to connect it to your computer just to see the output messages. So we need a screen. So one that we're going to talk about is the OLED, or the Organic Light Emitting Diode. This is essentially a similar concept to all the LEDs we used in class. They're just much thinner, much more flexible. You can get many more LEDs together in a dense bundle, and you can get bright, vivid colors. They're much more expensive. You see them in phones, TVs, laptops, things like that. But they're similar concept to the LEDs we've already used. So our micro LED, OLED, which just means it's very small, it has these two components. It has the component here, this red one, and the actual screen. And so let's look at each one. The screen, and you see the back of the screen right here. The screen is this component. This is the screen. Okay, and this part right here is actually the cable. Okay, and so the actual screen has all of these tiny little leads right in here. We can't even see them. And what happens is the cable connects to each one of those little pins. They're very, very tiny, and that's what you see right here. This cable, by the way, the yellow orangish cable, is very, very fragile. So you want to be really careful to not bend it. In fact, not even move it if you can. Ideally, on the back of your LED screen, there should be a little stick of kind of like foam glue here, and it flips up and cements to the red breakout board. Ideally, keep that taped back and don't adjust it. I have myself needed to reposition them, and the cable breaks easily, and then the device is basically useless. So just be careful with that. Our screen in particular has blue text on black screen. Other screens can have different colors, but that's the ones that we have. 64 by 48 pixels is pretty tiny. Your laptops are probably going to have 2,000 pixels in one dimensions, maybe even 4,000 or at least 1,000. So it's pretty small. Again, 3.3 volts, which is great. It has these two protocols that we can use to connect to it. You can think of a protocol like USB. USB is a protocol that we use. Well, here are the two that we use for these kinds of devices, and we'll talk about them as we go. It also has 31 pins, which is pretty outrageous. Thankfully, we're going to be able to navigate that a little bit. The next part, the red part, is called the breakout board. And the breakout board is basically a term when we have a component, like an LED screen, that's very tiny or very fragile. We're not able to connect that tiny, fragile component to a breadboard. And so what we have is often companies will manufacture a breakout board, meaning it allows us to break out those tiny pins into larger metal pins that we're used to in our breadboards. And so that's what a breakout board does. It just allows us to connect it to a breadboard easily. The nice thing is, once we use the breakout board, we actually only need to worry about 8 pins, which is really great. 8 we can kind of manage with our device. 31 wasn't going to be possible. So we only need to connect 8 pins, which is helpful. These are the 8 pins that we care about, and I'm going to walk through kind of what each one does. So the first two, pretty straightforward, power and ground. Always got to have that. The next two, we see SDI, SCK, and SDO. Okay. Well, what we need to know is that these two, these are data pins. And the SCK is the clock. So those are the 2 pins, or 3 pins, that would basically allow data to be exchanged. And we're going to explain how that works in a second. And then these final 3 pins, they're just sort of basic, almost like housekeeping pins that we need to connect. One of them allows us to decide if you're sending data that's going to be a command like reset the screen, or you're going to send an actual bit, pixel to show. Another one is a reset. Right? Sometimes it's useful to have a reset. And another is a chip select, which we'll explain in a second. So it would be really complicated to communicate with the screen. It would require us to write some pretty low-level C++ code that would be really intricate. And if you were in an electrical engineering class, we would probably do that. Thankfully, we're going to treat it the same way that we treat a printer or your Bluetooth headphones or anything that you connect to your computer or your phone. We're simply going to use a library. And this will allow us to use the library as sort of the intermediary between our code and the device. And it'll be much simpler for us to say, display this pixel here, erase this pixel here, etc. We're going to use a protocol. Remember, protocol is just like USB. We're going to use a protocol called SPI. And we'll explain the second one, which is called I2C, later in the semester. All right. First thing we need to know is, what is synchronous communication? So let's unpack this graphic a little bit. So synchronous communication, if we look at this graph here, what I want you to imagine is that there's device 1 here and device 2 over here. And so between those two devices, we have 2 pins. We have one pin that we're going to call the clock, and another pin that we're going to call the data. What's going to happen is device 1 is sending, so we'll say that, remember, the data is going this way. Device 1 is sending a clock pin, and the clock pin is, we say it's a square wave, right? So it goes up and down and up and down and up and down. Simple square wave. And it's like the metronome. It's kind of the thing that keeps the two devices in sync. And so while it's sending the clock pin, the clock pulse, device 1 is also sending the data through the wire. And it's basically just sending 0 or 1, right? So here we have 1, 0, 1, and so on. And what the clock does is the clock is the agreement between device 1 and device 2. And every time we have what's called the rising edge of the clock. Rising means I'm down and I go up. So every time we hit this exact moment in time, device 2 looks to see what data is being sent on the data line, and that's how it knows what should be sent. So for example, we get the rising edge right here. So device 2 samples this signal and goes, oh, I've got a 1. Next rising edge, it samples it, says I've got a 1. Next rising edge, it says I've got a 2. Oh, sorry, I've got a 0, and so on. And then this part we don't have to worry so much about, but what it would do, it would then assemble this byte of information into whatever data it was looking for. Now, we don't have to worry about how the assembly happens, but that's the idea. An analogy to this might be, if you told your friend you would tell them one word at the beginning of every minute, right? And then that's how you would communicate with them. Imagine it's like that. So at 12 o'clock, you say hello. At 12:01, you say I'm. And at 12:02, you say fine. Right? So it's simple, kind of like that. That's basically the signal of how this works. And so what we say is that this is synchronous because data is being sent at regular clock pulses, like a metronome. And then we say it's serial because data is being sent in a single line on one pin. Right? So this is synchronous serial communication. SPI is an example of serial synchronous communication. Now, so the idea of something being serial and something being synchronous, they're just concepts. So you could make your own protocol. So SPI is just one of many that people have sort of agreed upon. And there's 2 terms I want you to be aware of. The idea is main and secondary. And so the argon will be main. And what that means is that primarily it will be sending. Which makes sense because we consider the OLED to be output. And so the OLED itself, also called the peripheral, will be the secondary. And its job is to primarily receive. Okay? So this is the exact same picture, just illustrating it slightly differently. So remember I showed you a few minutes ago, we had on the actual OLED, we had 3 pins. We had SCK, MOSI, MISO. So this is just showing you another way that you might connect these pins and you would be able to communicate between 2 devices. So what we're looking at here is the pin called MOSI, M-O-S-I, stands for main out, secondary in. So this is, if the argon is the main, it's argon out to OLED in. And the MISO, M-I-S-O, would be main in, which is the argon, and OLED out. So this would be if, I'm going to say if here, the OLED sent data to argon. Now, for our purposes, this doesn't happen. The OLED is not sending any data to the argon, so we don't have to connect that pin. That's why the pin doesn't exist in our wiring diagrams. And then finally, we have the SCK pin. That's the clock. So for us to connect this device, we actually only need these two pins because data is being sent from the argon to the device, and the argon is controlling the clock, and that's it. But you might have other SPI devices that would send data back and forth. Now, just a quick word about these other pins. There is a pin called chip select, CS. This is if you had multiple OLED screens and you should turn one on and turn one off and send different signals back and forth between different screens, you could do that with a chip select. Now, we only have one, so we're just going to let the software handle that pin. We don't need to worry about it. And the other pin, this DC, again, stands for data versus command, which is, again, mostly the library handles it, but the pin is telling you, do you need to clear the screen or do you need to display a byte? So that's the difference. And if we look at the actual pin mapping, this is what you can use as a resource. Basically, we're showing you how everything gets wired. So, for example, we see that on the argon, this pin we had never used before, the MO pin, it's going to be connected to the MOSI pin on the OLED. And the SCK pin on the argon is going to go to the SCK pin on the SPI library. And then these other three pins down here, DC, reset, CS, there's no special pin on the argon for these OLED pins. So what we do is you connect any digital pin, right? These can be any. D0, sorry, D1, D2 rather, D3, D4, D5, D6, D7, whatever you want. Any pins that you have available, you can use those. And then in this library, we're going to say which those are supposed to be. So really the kind of the main neat thing that we look at are these two pins. These are sort of the special pins that make up our SPI. Finally, in order to use the OLED, we do need to connect a library. And so, like I mentioned, the library helps us communicate with the screen. And so the one that we're going to use with this particular product is the SparkFun Micro OLED screen.